Okay, so if you've been having trouble getting access, I want you to try to come to the preview week and use the authentication link here to get into the assignment. Once you're here, you'll go to Virtual Labs, CCNA, then click on the course, and you'll come down to the appropriate lab exercise. Now, let's see which module I need to do. I'm going to come back to my modules here and come down to the week 5, try it, and it tells me to go do applying security protocols. Okay, so if I scroll down and look through the different ones, you'll see 19 is applying security protocols. We'll watch that one. And once you launch it, it takes a few minutes for the devices to come up. Okay, so in this lab, we're applying security protocols, and we'll be using, or we will be doing these 4 exercises: configuring standard and extended access lists, configuring named access lists, and configuring access lists to restrict remote access. Then exercise 4 is configuring layer 2 security features. After completing this lab, we'll be able to create standard access lists, extended access lists, named access lists, and we'll be able to configure remote access, configure DHCP snooping, and configure dynamic ARP inspection, as well as configure port security. Okay, this is the basic lab topology. We may or may not be using all of those devices. Configuring standard and extended access list. A standard access list is an access list used for filtering traffic based on a source IP address. An extended access list provides more filtering criteria. You can add filtering based on source and destination IP address, as well as source and destination ports. In this exercise, we'll configure access control lists, or ACLs, to control traffic flows through the network. Okay, here we'll be using NY-Edge1 and the server PC. So I'm going to go ahead and turn it on. There are 2 types of lists, standard and extended. These access lists are referred to either by name or number, depending on how you configure them. The difference between the 2 types is by how they filter, or how the details with which you can filter. For example, the standard access list will only filter based on source, address, or network. This can be seen in the result shown below. Okay, so if we go in and run this command, that's what we'll see is access list 1 permit. And the above output question mark shows the options that are available at 2 different points before the network address is entered. You can see that you can enter the source address details. Okay, so in this task, we're going to create a standard access list on NY-Edge1. So I go to NYEdge1. This access list will match a single device on the network, specifically the server. Create a numbered access that matches the address of the server, which is 192.168.16.10, and choose the action to deny. The following commands, type the following commands. So we're on NYEdge1, and we want to go into configuration mode and set our access dash list 10 deny host 192.168.16.10. Okay, exit. Okay, so now we're going to do a show access dash list. And you'll now see the address for that 10 deny 16.10. As there is an implicit deny at the end of each access list, you will need to include a permit statement, otherwise everything will be blocked. So we type the following commands to allow all other traffic. So go back into configuration mode and access dash list 10 permit any. At this point, the access list has just been defined. We didn't apply it anywhere, so filtering has not yet taken place. We have to bind this access list to an interface, and careful consideration has to be taken when applying the access list. Should it be placed as close as possible or as far away from as possible from the source? And in what direction should it be applied? For example, should you place the access list on G00 or G01, and in what direction? In this step, we'll place the access list on G01 in an outbound direction. Okay, so we go to interface G01 and set up IP access dash group 10 out and exit. Okay, connect to the server. I have to scroll down a little bit and I can right click on the icon in the corner and run the command prompt as admin. Then I want to ping www.practice labs.com. Our ping should be successful. Okay, we're going to go to NYEdge1 and use show access dash list. Not in configuration mode though, we have to go back a layer and show access dash list. You can see here that there's 4 matches on the permit. Actually, I got 8. Maybe I did it twice. And no matches on the deny. examine the configuration again, and you may realize that something is wrong. If the server has an IP address of 192.168.16.10, then the ping should be denied and not permitted. Why is the incorrect line being matched? So we're going to find out. And what we're seeing is that placement of the access list is important, because right now it should be denying there, not matching, because of the entry in our list. But it didn't, because network address translation is working on this router, and the source address of the server is being translated. Remember, we did that a few labs ago. When the packet in question is exiting the G01 interface on which the access list was applied, it no longer has 192.168.16.10 as the source address. It's been translated. Therefore, we must either change the access list placement and direction to G00 inbound, or you must modify the access list to match the translated IP address. Best choice would be to change the placement and directions. We're going to remove the access list from G01 interface and place it on G00 in the inbound direction. Okay, so we'll configure terminal and go to interface G01 and no IP access dash group 10 out. And exit, and then we'll go into interface G00, and we're going to set up IP access dash group 10 in, and exit. Alright, now we're going to go back to the server and retry the ping. Notice now the ping is unsuccessful because we changed the port and direction of the filter. And now I'm going to connect to NY-Edge1 and show access dash list. Now we can see that there are matches on the deny list. Before continuing on, we have to remove the access group we applied to G00. So we'll go to interface G00. And no IP access dash group 10 in, and exit. Now we're going to create an extended access list. The benefits are that you can be more granular in what you want to permit and deny. In this task, we're going to create an extended access list. You will now configure an access list that permits FTP but denies ICMP on NY-Edge1. Okay, so on NY-Edge1, we're in configuration mode. We'll set our access dash list 110 to permit TCP host 192.168.16.10 any EQ FTP. Access, and then we add dash data, use the up arrow and down arrow to scroll through previously typed commands. So we're setting 20 for data and 21 for control. Those are well-known ports, so you can go look those up. Within the same access list, we want to deny ICMP specifically to practicelabs.com, which corresponds to the IP address 172.15.0.10. Remembering that ICMP is a protocol, type the following commands. So we want to access list 110 to deny ICMP host 192.168.16.10 host 172.15.0.10. Access list deny ICMP host 190. Oh, hostess. There we go. It's weird they don't always put their markers in the right places, but hey, nobody's perfect. All right, then we'll exit here and do a show access dash list 110. And you can see there are the two that we just added. Okay, now we're going to apply the list to the interface G00 in the inbound direction. So we'll go back into configuration mode and go to interface G00 and set up the IP access group 110 in and exit. You can only have one access group per interface per direction. The above command will replace any other inbound access group that may have been configured on the interface. All right, so now we're going to the server. First, we're going to do a ping. Okay, and the ping does not go through, but then we're going to go test our FTP using oops. And now we want FTP to practice-labs.com. And you'll see I'm able to get in because I'm doing FTP. And I'll use anonymous. And for password, just hit enter. And that shows I got logged in to the FTP portion of the server. Or I got FTP'd into the server. Alright, so now we'll go to NY Edge 1 and they want us to show access dash list 110. Okay, and you can see now there were matches for the FTP. Okay, so back into configuration mode to interface G00, and we'll remove the access group 110 and exit. Okay, now we're on to exercise 2, configuring named access lists. On the previous access, we configured standard and extended numbered access lists, and this exercise will create the same access list, but this time we're going to name them. In this task, we're going to configure the named access list to allow FTP traffic and the Cisco tool server to host 172.15.0.10, but deny ICMP traffic between these two hosts. So first we create the named extended list called FTP permit, which allows FTP from 192.168.16.10 to 172.15.0.10. In the same access list, we block ICMP. Okay, so we make sure we're on NY-1. We're currently in configuration mode. So we'll set IP access dash list extended and name it permit dash FTP. And permit TCP host 192.168.16.10 host 172.15.0.10 EQ FTP. And you'll want to notice our prompt here too. And we also want to deny ICMP host 192.168.16.10 any, and exit. And now we're going to create the access list permit dash FTP, and so we didn't include the line which permits the FTP data port. One advantage of using the named access list is that you can insert entries into any position of the access list, assuming there's a line number free where you want to insert the new entry. Line numbers are by default are assigned in the tens for this purpose. The new line should be placed in between existing access list entries, numbers 10 and 20. So we'll put the FTP data line in at number 15, allowing you to add future entries above and below that point in the future. Okay, so we'll go back into configuration mode and set the IP access list extended permit dash FTP. All right. And now we'll add line 15, permit TCP host 192.168.16.10, host 172.15.0.10, EQ FTP data, and exit. Okay, now exit again and do show IP access dash list permit dash FTP, and we'll now see line 15 that we added. Okay, now we have to apply the named access list to the interface that we need it to go to. So we'll go back into configuration mode and go to interface G00 and IP access dash group permit FTPN. Permit dash FTPN and exit. Okay, now we're going to come check all that out. We'll come back down to the server. And I'm going to close this one out and open a new one. And ping www.practice-labs.com. And again, our pings should be unsuccessful. And I'll also do my FTP to www.practice-labs.com. And didn't log in here, but you can using the anonymous and enter as we did before. So now we're going to go to NY-Edge1. When troubleshooting connections through the access list, sometimes it's helpful to reset the match counters. In this step, you're going to clear the counters. Okay, so we'll do our show IP access dash list permit FTP permit dash FTP, and we see the 3 lines we put in, and there's matches here and here. And actually, if I go back to here on the lab and log in ANONYMOUS, anonymous, and come back to NY Edge 1. We'll see now we have a data because I did a check there on the directory, and now we have our permits for the FTP data and the deny as well. That was our ping. Okay, so now we're going to clear IP access dash list counters. And then I'll do a show again, and now you can see all the matches are gone. Okay. For finishing this exercise, it's important to be able to see what access lists are being applied to an interface. Here's two approaches you can use. First, you can view the running configuration. Show run at G00. You can also use the show IP interface command. This shows which inbound and outbound access lists are set. So we'll do show IP interface G00. Okay, now we're on to exercise 3, configuring access lists to restrict remote access. In the previous exercise, we created access lists that block network traffic flowing in or out of a router's interface. What if you wanted to restrict which IP addresses could actually access your router remotely? In this exercise, we'll look at this further. Okay, so we're using NY Edge 1, Edge 2, and the server for configuring remote access. And here we'll use our knowledge of access lists to restrict access to Edge 2. For this purpose, we'll create a standard access list and apply it to the VTY lines. When you apply access lists to VTY lines, you limit users that have SSH telnet access to the device. So connect NY Edge 2. First, to prove that access to the router will be blocked, you must first configure a password so that when you use the server to access the router remotely, you can actually log in. So we're on NY Edge 2, I'll enable and configure terminal and go to line VTY 0 space 15 and set the password to Cisco and force login. Not till I spell password right though. And login and X. Whoa. Okay, so yeah, that's where we were. And step 2, we're going to create a named standard access list called permit remote, allowing 192.168.16.10 and denying anybody else. Add the log keyword to deny any entry or in order to log all denied attempts. Alright, so again we're on NY Edge 2 at the configuration prompt, and I set IP access dash list standard and name it permit remote. And I'll permit host 192.168.16.10 and deny any and create a log of attempts. Exit, and now we're here. So we have to apply the access list to the VTY lines. This differs a little bit from before. On the VT lines, you must use the access class command. Remember that the VTY lines are essentially virtual connection points where remote connections via Telnet or SSH can be established. Alright, so we'll go to the line VTY015 and access dash class permit remote in. Exit. Next we'll go down to the server. To confirm the configuration, we're going to use the server to telnet to the router. We use PuTTY. Oh, come on. Make sure we're set to telnet, and up here for the IP address 192.168.16.2 and open. Then our password should be Cisco. It does not echo, so you just type and hit enter. Okay, we successfully telnetted in. And we can type enable. And there's no password set there, so we cannot get in. Okay, so we're back to NY Edge 2 and exit from there and show access dash list. And there were 2 matches. All right, now we'll connect to NY Edge 1. And on NY Edge 1, we want to telnet to 192.168.16.2. Then we're going to reconnect back to NY Edge 2 because we configured a deny log at the end of the access list. If you look at the console of NY Edge 2, you should see the following syslog message. Access lists have many uses, and securing access to your devices is very important. It should be done on all your networking equipment, especially any devices that are exposed to the internet or in any unsecure environment. Alright, now we're on to exercise 4. Configuring layer 2 security features. Sometimes a network could have traffic that is malicious. These types of traffic, let me turn this off. These types of traffic cannot be filtered with an access list. For example, if we have clients that are configured to dynamically get an IP address from a DHCP server, there's a risk that an attacker can set up a rogue DHCP server and provide an IP address to a client using his IP as a gateway. Client's network traffic would then directly travel to the attacker. Layer 2 security features provide another aspect of security on Layer 2 where you can protect your users from illegal DHCP servers. This is called DHCP snooping. You can also configure MAC address filtering per switch port and prevent illegal PCs from getting access to the network. In this exercise, we'll learn how to configure different Layer 2 security features, DHCP snooping, dynamic ARP inspection, and port security. We'll be using NY-WAN 1 and NY Core 1. And task 1 is configuring DHCP snooping. When a DHCP client wants to get an IP address from a DHCP server, a broadcast DHCP discover message is sent to the DHCP servers requesting an offer. When a server gets that message, it sends an offer message that contains an actual IP address. The DHCP client accepts the first offer by sending a DHCP request message back to the server. When you enable DHCP snooping on your switch, you are actually telling the switch to track DHCP discover and DHCP offer messages. When you enable DHCP snooping on a switch, all interfaces will be in an untrusted state, which means they will block the DHCP offer messages. If you leave it like this, you will block a legal DHCP server on your network too, as well. You need to trust the interface where your DHCP server is connected and also configure all uplinks to other switches as trusted. In this task, you configure NY Core 2 as DHCP client and NY-WAN 1 as a DHCP server and enable DHCP snooping on NY Core 1. Okay, so we start by connecting to NY Core 1 and enable DHCP snooping for globally as well as for VLANs. Okay, so enable, configure terminal, IP DHCP snooping, and then set it to VLAN 1. And then we'll set no IP DHCP snooping information option. By default, the switch adds option 82 to the DHCP discover message before passing it to the server. The server then drops those packets. You need to disable this feature on a switch. So we're going to connect to WAN 1 and configure it as a DHCP server. You'll make the server assign IP addresses in the range of 200 to 254. So IP DHCP excluded dash address 192.168.16.1 space 192.168.16.199, and we'll create a DHCP pool called pool and tell it the network 192.168.16.0 255 255 255 0. network, and we'll set the default dash router to 192.168.16.1 and exit. Okay, so now we're going to NY Core 2. Configure terminal. Interface FA1023. Set no switch port. IP address DHCP. I think I don't know. DHCP. And no shutdown and exit. You now verify if the port has received the IP address. To do this, I'm going to show, exit again, and then show and FA1023. Notice from the output, the port doesn't have an IP address assigned to it yet. You'll now make the port where your DHCP server is connected as trusted. So we're going to come back to NY Core 1 and go to interface FA102 and set IPDHCP snooping trust. Okay, did I get my interface wrong? Oh, no, I still can't, I just can't spell. Snopping? Alright. Okay, now we'll verify if the client has received the IP address, so we'll go back to NY Core 2 and do our show interface again. Come on. And we should see that it now has an IP address. Or ours still says will be negotiated using DHCP. Dynamic Arc Inspection, or DIA, is another layer 2 security feature that protects a switch from an attack like ARP poisoning. It checks all the ARP packets on untrusted interfaces and compares it with the DHCP snooping database. If the information doesn't match, it will drop the packet. In this task, you'll configure an IP address on NY Access 1 switch, and you use the same IP address that the DHCP server assigned to NY Core 2 in the previous task. You will also try to ping the DHCP server NY-WAN 1 router with a MAC address that's different from the one that NY Core 1 has as its DHCP snooping database. So first you check the DHCP snooping database on NY Core 1. So we go to NY Core 1 and enable and show IP DHCP snooping binding. And now we'll configure ARP inspection on NY Core 1. IP ARP inspection VLAN 1 exit. Now we'll go to NY Access 1 and configure the interface VLAN 1 with the IP address 192.168.16.200. This address is already available in the DHCP snooping table on NY Core 1 switch, but it's bound to another MAC address, the MAC address of the interface FA1023 on NY Core 2. So by creating the same IP address, you're simulating an attacker on a network. Okay, so we go to NY Access 1 and enable CompT. Go to interface VLAN 1 and set the IP address to 192.168.16.200 space 255.255.255.0 and exit twice, and we get the following output. Now we're going to try to ping the DHCP server from NY Access 1. So we'll go to NY Access 1 and ping 192.168.16.3. The ping should be unsuccessful. Go to NY Core 1, check the not log message, and you'll see we're getting DAI is blocking invalid ARP messages. Okay, so now we're going to configure the port security. When you configure port security on a switch, you're actually telling the switch to filter the MAC address. In this task, you will enable port security on NY Core 1 and check what happens with the port when you violate security. Connect to NY Core 1, check the MAC address table. Show MAC address dash table. There we go. Notice that FA024, we have 3 MAC addresses that are learned. We'll now enable port security on the FA1024 port and limit it to just 1 MAC address. So on NY Core 1, we'll go to configuration mode and go to that port FA1024. Set switch port dash security. says it was rejected because it's a dynamic port. Alright, so then we'll switch port mode access. And now try switch port security. By default, when you enable port security on the port can learn only one MAC address. When port learns the second MAC address, there will be a violation in port security and the port will be put in an error disabled state. You can change this behavior by allowing the port to learn 2 MAC addresses on this port. Change the maximum number of MAC addresses on this port to 2. And to do that, we set switch port security, maximum 2. Okay, and since the port is in an error disabled mode, type the following command: do a shutdown and then a no shut. Okay, and now we want to do a show port dash security. Notice the default violation action is the shutdown port. This can be changed by issuing the following commands. Go into configuration mode and go to the interface FA1024. And we set switch port dash security violation. And here they're wanting us to look at the options. Switch port security violation question mark, and I'm still not getting it. Switch port security violation question mark. There we go. And we get 3 different: protect, restrict, and shutdown. And the first 2 options, the interface will not go to error disabled state and will stay up and running. It will only block frames for the MAC addresses that violate the port security. Traffic from legal MAC addresses that don't violate port security will be allowed on the interface. Now we've completed our Module 5 Try It, and we've configured standard and extended access lists numbered and named. We configured remote access and limited or restricted remote access. And then we configured layer 2 security features. Please let me know if you have any questions.